Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. And Fred and I were following on our conversation about this thing called CPK.
Yeah, it's I think the gist of our thought process, one, it's a reliability element. We got to get it right from the design. And I think, at least in my experience, and I'm sure from the way you were talking, Chris, we found that there's often a disconnect between the people that, and some of it is due to, we have contract manufacturers. We have all these vendors and outsource stuff that, are trying to build what the team designs. So we have a widget and we want to get it built. And it's a pleasure these days when you actually work with somebody that has their manufacturing is in-house, and communications are usually much more streamlined. But even in those cases, whether it's all in-house or it's spread out all over the world, connecting the design intent, what I'm trying to do as a designer team, into this is what it should be when it's done, and here's how the pieces should fit, and here's all the drawings and all the intent and critical quality and all these other aspects we use to actually achieving it. And it reminds me of, and I'm sure, Chris, you've never worked in a place like this, where the design team creates a beautiful set of drawings and design and everything else, and today they would email it, but apparently they used to just throw it over the wall and over to the manufacturing team, and then they would go figure out how to make it. It's not a one-way conversation. And I think CPK is a pivotal communication tool between these two entities, the group that is creating the concept of the product, the design, and the group that's creating the physical entity of that design, the product. And CPK is a phenomenal tool to convey this what's possible versus what's not possible. Now, one quick story is my first real introduction to this. I was a design for manufacturing engineer. So I was reporting to and living with the manufacturing team, a line that made electronic circuits. And I was supporting one product, and particularly one circuit board for this product. And so Ed was the electrical engineer for that product. And after a few months of working with him, every time I show up at his desk, he would sigh. He was just sad to see me. Was, oh God. And I said, what's the matter? And he goes, well, you either tell me what the manufacturing process is not able to do, and I have to change my design, or you want me to change the design so it's easier for you guys to manufacture it. Why don't you just build my design? Kind of thing. They're like, well, do you want it to actually work? So, but he didn't like the way I was approaching him, because I always brought him problems. I never brought him solutions. But I quickly learned CPK because he did care about yield. He did care about the product working. And so we used CPK kind of numbers to say, well, if we put these two parts this close together, I'm going to have this kind of fallout. Here's the data. And that leads to, $800 billion of repair work, and half the products will fail in the field. Do you want to do that, or should I tell your boss? Kind of thing. So he still didn't like it when I showed up.
Yeah, and just for the uninitiated, CPK is a measure of the extent to which a usually manufactured characteristic is within specifications. I mean, it's often assumed to be the bell curve that describes that natural variation, and if it is, for example, life is good, and a CPK value of 2 means that there is 12 standard deviations worth of variation within the specifications. And if the CPK is 1, which is considered a very low value, there's 6 standard deviations worth of variation within the specification limits. And these are somewhat arbitrary numbers. They are useful in that it's a really good way of quantifying any improvements of your manufacturing process, which is obviously a thing you want to be able to measure and acknowledge and strive for.
Well,
But
the issue is, Chris, is yield is often where this gets introduced. A production line has it, and they're saying, well, we're trying to meet these specs. We have this end of line test, and it says pass fail here. And if we improve the process so it has less variability, or it's more centered, or all these other ways of improving CPK, then we have less of a yield issue. But as a reliability person, I look at that as being just the tip of the iceberg, to use this old analogy, because we have measurement error. We have variability in how the product is used and down the road. And if it's close to the edge of the specification, it's much more likely that it's going to fail in the field. So keeping things well away from the specifications. Now, assuming the specifications are meaningful, right? And that's a big if. If we create products that are a low amount of variability versus what they need to achieve to perform well, then the CPK values will be high, life will be good, the product will work in the field. And yield is easy to measure because we can do it right away. But field performance, because of increased wear or increased heat or increased susceptibility to bending or cracking or whatever realms it are, is that when the product is made on the edge of the spec, it's not that it will work. It'll work today, but it's more likely to fail than products that are centered on the design intent. And of course, assuming the design is actually good. So there's that part too.
That's where, the whole concept of Taguchi's loss function becomes relevant. And
Yep.
Again, so for those who are unaware, this Japanese dude called Genichi Taguchi, in the 60s and 70s, he came up with this concept of a loss function to describe how good or bad your part was. And a very Western way to look at quality was, if the tolerances are this, or the upper and lower specifications limits are these numbers, as long as the part is within those specifications and tolerances, it's 100% good, regardless of how close it was to the edge of the specification. After all, if it's a specification limit, why would you specify a single number if there's grades of badness? But the reality is, of course, there is. It's very hard to specify, a beautiful curve of loss for each deviation away from some central or nominal value.
Mm-hmm.
And essentially, Taguchi defined his loss function as loss incurred by society as a result of deviation away from a nominal and target specification or value. And of course, a lot of people rolled their eyes and said, what tree-hugging, drug-smoking nonsense is this? But that's because they weren't looking at the key message. And what he was saying was, look, you can manufacture something, but if it's close, if it's within specifications but only just, then that's going to be the product which wears out early in the field, or that's going to be the product which experiences tolerance stack up and you can't put together, or that's going to be the product which, because of this, or because of your characteristic being away from the nominal value, has a pre-stress which accelerates fatigue growth.
Mm-hmm.
Or that's going to be the product where if you have any variation or any issue with manufacturing on that day, it's going to be outside of specification. So what he was essentially saying is, look, we can't possibly hope to model every single cost incurred by having something within specifications, but only just. And so he came up with an equation which gave us a curved line as opposed to a binary yes or no. And it is a very useful way of looking at whether your manufactured part is good or bad, because you always incur some sort of loss when it deviates away from the nominal or target value that the designer had in mind. And even if it is within the specifications, there has been example after catastrophe, after crisis, of things that were built to spec that have failed or exploded spectacularly when they've been used in the real world because quality was not the number one consideration by the manufacturing team. This just happens over and over again.
Yeah. No, Gucci was onto something there, and it is, and but the key piece of this, in my mind, is that the design team, when they're setting the specifications, have to do two things. And I've seen this done in a number of organizations that, in my mind, get it right. Is they have to be familiar with the manufacturing processes that they're invoking. Is it a stamping process or a drilling process, or is it a laser guided cutting tool, or is it, what's the inherent ability of the manufacturing tools that you're using and you're calling out to the manufacturer of your product. So that takes some knowledge, it takes some experience to know the basics of these things. And there's guides and books, and different organizations create this information. Now, the better ones go to their vendors or their manufacturing floor and say, all right, cut a hole, right? And they measure how precise it is and how much variability it is. And then they can calculate the standard deviation of that process, right? And then they go back to their drawings going, well, given that amount of variability that we see inherent in that process, then I have to create a design that accommodates that. So I need to create specifications that are okay with that amount of variability. And I think that's the central core of the question from the design team, is understanding the process, but getting the data for those critical to quality things, the essential elements of their design, and then build that into the design. Now, can I make that? And it goes back to the discussion that you were talking about in our last episode, is that now I can use that CPK and the quality budget to say, well, I'm going to trade off these three things and I can still achieve the objective, but I can maximize the ability of these three different parts of our process to achieve it, as opposed to arbitrarily doing it. But more importantly is that it gets considered in the design process of, are we using the right manufacturing process? Is it even possible to get to where we want to go? Or are we going to accept this amount of yield loss and failures, or what else we have to do? Or do we need to change the design in a fundamental way?
Yeah.
It's that back and forth that I see many organizations miss.
In some organizations, it's not only back and forth, they don't even involve any considerations for manufacturing when they come up with that first design. And a lot of organizations also tend to have their hierarchy dominated by the design people. The manufacturers are often, unfortunately, seen as the poor cousins to the real heroes who design something magnificent. And then all the manufacturing team does is find ways to
make it worse. No, you're in trouble if the only place you see CPK talked about at all is the procurement team has it in their contract that every part, every piece, every shipment you send us, you have to send us a CPK value for that lot. And it doesn't go anywhere. Nobody ever sees it. It's just checked off that, they send us their control chart and the CPK value. And nobody looks at it. Nobody uses it. You're in trouble.
And actually interrogating your suppliers to understand their approach to SPC and at CPK and lots of other acronyms, which might not mean everything to some of our listeners, but those are key acronyms in the world of quality that if you actually engage your suppliers and work with them to get the numbers you need for your design to work, that's where all of a sudden you start to be a profitable, high quality company, which doesn't spend all of its time putting out fires and yelling at people for ruining the genius of some other favored group of people.
Yeah, no, I did have that conversation with the designer once. I was a manufacturing engineer in a plant, and he came down with this product and said, we need it made like this and hit this target. Okay. I can't do that. He was like, what do you mean you can't do that? And he says, you want it to be exactly 48, ohms resistance on this measurement we make. And there's absolutely no way I can guarantee that I'll get 48. What's the leeway I get? Oh, it has to be 48. All right. Well, then you can't have it because there's no way I can guarantee that. Now, he went back, yelled at my boss a little bit, and my boss yelled back at him and said, say 48 plus or minus 4.8. And okay, I can try for that. And then it evolved into this was a critical dimension and all the other things they wanted. So we ended up doing process control and CPK values and found out that there's absolute 3/4 of the products being made would be scrap. So that project got canceled. He never talked to me again. That designer. It was,
oh well,
yeah, it wasn't a big loss. I don't think.
Reality can be a bit of a bitch sometimes, can't it?
Yeah. Now, when so there's another piece to this though, is the design team has to make a balance between. Now, one of the stories it dawned on me is that there was a rifle, and I have no idea who was making it, but it was one of the first interchangeable parts, like in the 1700s, 1800s type thing. And so they're able to mass produce it, right? Was that, I don't want to say Smith & Wesson, but that's just the only gun name I know.
I'm at a complete loss, so I can't help you.
But no, they had in a rifle, there's only like 4 parts for a clever design that came out, and they wanted to mass produce it. And I don't think they had the concept of CPK, and they weren't making measurements, and they were casting these things. But I suspect that design said, I'm going to give up on some of the compression that occurs and the speed of the bullet and the range we get. We're going to give up on some of that so that given the way we make these things, that you can interchange the barrels, you can interchange the trigger mechanism, you can interchange these things, and they all just fit, but just good enough that you have a functioning piece of equipment. But we're not making it so precise that you maximize the range or maximize the accuracy or anything else. We're giving up on some of the performance to accommodate the ability to make repairs quickly in the field, for example. And so I use that as and I know somebody's going to know what that story is, but it was pivotal instead of having custom made weapons on the battlefield that had no spares. Now you had a supply chain that actually could keep your soldiers armed in an efficient way. A lot of things get invented in wartime. It's amazing.
Well, another rifle of note is the AK-47, which is a Kalashnikov devised 1940s, I believe. Anyway, yeah. So it's a Soviet engineer who came up with this rifle, and he focused on not so much interchangeability, because by that stage, the Industrial Revolution had already happened. So
right.
That was already a thing. But he focused on creating a really simple rifle, which was robust, which no matter how dirty it got, no matter how wet it got, it just worked. And
right.
It didn't have the same recoil characteristics. And a lot of the parts were deliberately made out of wood, because then even out in the field, you can be surprised what soldiers can do out in the field if they have a bit of downtime and a bit of a tree nearby. You'd be amazed what they can replace on a rifle with a little penknife.
Yeah.
But the AK-47 is widely known as an extraordinarily reliable rifle. Not just reliable, but robust.
Robust. It works under any conditions, pretty much.
Yeah. You're going to die before. Oh, sorry,
that's probably not a good analogy there, but
yeah. So my point was, you're going to break before your rifle breaks.
That's right.
And you see this rifle, which has gone through precious few technological updates since back in the 1940s, and it's used in the battlefield across the world.
But that was a design intent, right?
Right.
Where it accounts for the variability in the environment, and
right.
So clearances and functionality was not dependent on it being pristine and clean and smooth running and everything else. And the same with the earlier one, whereas we want it to be interchangeable. So we're going to give up on some performance of these custom handmade ones that had, really nice performance. We're going to give up on some of that so that we can make a lot of them. And so it was a different design intent, but it was accounting for the variability, whether it's manufacturing or in the use environment. That's critical in a design. Now, I've talked to so many designers that, well, I'll get to that after I get one to work, which is fair. You got to get the concept to actually do what you think it's supposed to do. Then let's make it robust, or let's make it resilient, or let's make it manufacturable, or let's make it repairable. But you have to pick one. And I think organizations try to get, well, I want these 5 features. And then they forget, where are we going to prioritize? Are we trying, is it to work in all environments, or is it to work in, all these other aspects that affect the reliability, performance of the product and its functionality in all these different variables? And that's part of then saying, well, what is the critical elements of this design that I need to make sure work? And that's where CPK discussions come in, right? It's where do I need to focus on these dimensions that are essential for it to be repairable, or essential for it to be interchangeable, or essential for it to work in all conditions. That needs to be narrowed down. And that gets it to that critical few sets of dimensions or elements that then we can go, are we able to do that? And that's where CPK kind of measurement and discussions come in.
But the reality is that, and so it's honestly loath to admit that, admit this. When they say, we'll get to the robustness once we got, I suppose, proof of concept worked out. Yeah. That if that's genuine, fantastic. But often it's just used as a throwaway line to say, stop bothering me. I want to just get out of the way of my genius. So I'm going to create this fantastic, sophisticated, elegant piece of whatever. But unfortunately, if the relative humidity is below 32% or above 36, it's going to melt. That's
yeah.
But the AK-47, I think, case study isn't finished yet, because there's the M16, which was essentially the American response to an assault rifle vacuum from World War II.
Yeah.
And the M16, which was first used really in anger in Vietnam, was notoriously awful when it came to reliability. It was one of those rifles, if the relative humidity wasn't between 32 and 36, it just did not work. And many soldiers in the Vietnam War actually tried to capture AK-47s because they just
worked. Yeah.
Yeah.
Yeah. No, I know that. I was in the U.S. Army shortly after Vietnam. Luckily, it was after that was an active event. But plenty of the people in the military were from the Vietnam era. And it was just, I do not like cleaning rifles.
Right.
But it was just drilled into you that if it's not clean, it's not going to be useful for you.
Correct.
And
I've done patrols in the jungle in Southeast Asia, and it's very hard to keep a piece of kit clean in that environment. It just really is. You have to, when you really think about it, you might need to cross a river.
Yeah, or swamps, and there's stuff dripping out of the trees on you, besides the spiders and snakes,
and usually it's just as wet in the air as it is in a river.
Yeah.
But then compare that to an AK-47, where you can just walk with it through a river, let the water drain out, and it will fire. And it's just not a problem. That's not just not the eradication of a nuisance. That is a capability that rifle has that the M16 never had.
Well, but that goes to the story of if whatever the design is what is the critical application of this thing? What is it that makes or break it for the customer when they need it to work? If I'm a delivery truck and I'm relying on that backup camera to work so that I can do my job, because I don't have adequate mirrors, everything else is dependent on this one camera going, that better work, right? And the systems and backup, or maybe even redundancy, would be part of that discussion and design. But if it's just everybody puts backup cameras on stuff, so we'll just stick it on here, but it's the angle it's attached is flaky. It doesn't have a good way to align itself. It doesn't have the field of vision that it's supposed to have. All those variables matter. And if it's not thought through, that poor driver is stuck with a capability that just is not serving them. And it affects it. So I'm taking it out of the military a little bit, but it affects performance, whether it's a delivery driver or a soldier. the design of your product has to be connected to what's important to its functionality. That's reliability in my mind, right? The camera might show stuff and electronically it's connected. And so we might say it passes, but if it only shows the left side of the bumper and nothing more than 1 foot away from the back of the truck, it's not terribly useful.
Yep.
So, and I'm being a bit facetious, but there's too many designs that are beautiful in concept and horrendous in application because the design team does two things wrong in my mind. Is that what is not identifying what is important and identifying that those are the things we need to make sure work. They're oftentimes called critical to quality. And then the second part is, well, are we even able to create that in the manufacturing process or in the use environment? And if those two pieces don't go, the design could be beautiful, but it's worthless. And that's not a good place to be in.
No, and and there are plenty of examples out. Like smartphone manufacturers, essentially the ones that are in play today, are ones that have been able to manufacture reliable smartphones. They're all elegant. You look at each smartphone design; they're all elegant. But if you rewind 10, 15 years, there are a lot more phone players in the market. Nokia used to be the biggest cell phone or mobile phone player in the market, and they made some poor business decisions after the success of their 3210 bricks, and there's Apple and Samsung, lots of organizations.
Research in Motion, the BlackBerry, I think they finally dropped support for that now. It's just not even going to be. It's going to be just a piece of equipment that doesn't connect to anything.
That is a podcast in its own right. How BlackBerry just can just drove itself off a cliff.
Yeah,
it's sad in a way, but it's also, it just goes to show how an organization can swing from really creative thinking to let's just stop thinking at all.
Yeah, well, they're a poster child for that, and there's a handful of other stories there. But anyway, I think we've got our point across, is that CPK is part of, as we talked about in the last episode, of, it's what it is and how to use it and elements it fits into and how to set goals for it. We did that in brief. But the other piece of this is in the design and design intent and the information that goes back and forth from the design team to the manufacturers and suppliers and other critical elements, so that you do end up with a design that CPKs are meaningful and useful for the entire process. So there's a bunch more into this, 20 minutes of discussing it a couple of times isn't going to cover it, but I think you get the idea that this is part of the kit for us in the reliability world. And in our work with design teams and with manufacturers and suppliers, it's a valuable piece of information to use when done well.
Right.
So if you got some thoughts on that, if you use it well or don't use it well or have some questions, let us know. Join the conversation over at accendoreliability.com/go/SOR. You can find a contact form. You can find a widget to leave us a voice message. Chris and I and the other hosts are active and available through LinkedIn or our About pages. Plenty of ways for you to join the conversation, and we'd love you to do so. So,
absolutely.
Yeah. So I think I'm going to figure out what I'm going to do for the rest of the day. I think my range of variables is beyond comprehension.
Yep, and according to my children, my capability index is quite low in not just statistical fields, so I'll have to go get creative.
There you go. All right, well, have a good one, Chris. We'll talk to you soon.
You too, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.